So hi, Professor. Hi, this is Team Triangle, and I'm Chan Han. Today, me and team members are going to talk about the cross-site scripting XSS. And firstly, I will introduce about what this attack is, and I will do a short demo on the DOM-based XSS attack. And then Hao Zhang will do the reflected XSS attack and one stored XSS attack. And then Marlon will talk about the how we prevent these mitigations. So firstly, what is XSS attack? So this is a web vulnerability where attackers inject malicious script into pages viewed by users. And actually, now there are three main types of the attack. Firstly is a stored XSS, which was a malicious script comes from the website database. And also the second one is reflected cross-site scripting, where the malicious script from the current HTTP request. And then the third type is a DOM-based cross-site scripting, with vulnerabilities existing in the client-side code rather than the server-side code. So basically, I'd like to show you a short demo of how the DOM-based attack happened. So today I'm going to explore a block comment section to trigger the alert one. Then I will show you how to solve this problem. So here is a lab that I'm going to conduct, and here's a website, and we can see that there's a comment space that we can leave some comments, and then we can check the network. By refreshing this, we can check the that just a pop-up straight away when opening the developers of JavaScript file, and the name of the JavaScript file is load comment with a vulnerable escape HTML. So the file is actually named after the type of vulnerabilities, which is presumably that's something we're going to find with a while, but it gives us an immediate clue where we are going to look and check regarding the escaping of the HTML. So we are going to create with this clue that we can find that how we can explore this function to escape the HTML, because according to the title of JavaScript file, it's going to be vulnerable. And we notice the function here, the escape the HTML. It takes some HTML code as an argument, and the object of this JavaScript function is to replace the left and right angle brackets. So obviously, if we use these angle brackets directly, it could result in HTML injection. So idea is to replace the angle brackets with their HTML encode from so instead of the left angle brackets, and we can have ampersand left LT, and instead of the right angle bracket, we can have the ampersand GT. Now it might not immediately be clear why this is vulnerable JavaScript, although it is vulnerable, and if you understand the replace method works in JavaScript. And now here's a way that we can check the what was. Let's assume that we don't know why this happened, so we can do some tests. First, we start trying to injection HTML and see what's handled. Here we can have a very simple H1 tag, hello world, hello. And then we leave the comment. Yeah. Randomly type something. Yeah. Oh, it's going to ask you to. Yeah. So here I already leave the comment, and then we can check what we have left. So you can see that here the H1 the left bracket is still there, but you can see the right side already be hidden because our we see the H1 rendered to the page now, and what it means that H1 has been successfully escaped. It's been successfully replaced with the HTML encode version of a left bracket. If it wasn't, we could see the left, but we can only see the right. So this is really interesting because we didn't see the closing H1 tag, and the logical assumption is that whatever reason what closing H1 tag was not being HTML encoded, in other words, it being rendered the page in fact is rendered to the DOM. In case the reason why we say it's rendered to the DOM, that's not a part of the original HTML is delivered when we make HTML request to this page. Because we can see that from the function, it uses a function name replace. So here we can make use of this vulnerability and conduct today's attack. So we can think about it how we are going to inject the payload that we're going to inject here. So we can type by crafting a payload with an extra set of angle brackets. we can bypass this incomplete sentence, enable the injection to be executed HTML into the document at the DOM-based attack. So here I will type the payload. The alert one, which is the result we want to achieve. Then we will leave our comment. So after we make the comment, we click back to the blog, and then we can see the thing that we achieve. We already achieved the flag, and we get what we want. So it successfully executed of this attack triggers an alert one pop-up, proving the feasible of the script injection and highlights the risk posed by the inadequate input handling.
All right, let's dive into our second lab. Our goal here is to use the stored cross-site scraping to steal a victim session cookie. And picture to the scenario, we have got a blog with a comment section, and it's not properly filtered input. That means an attacker can inject a malicious script right into the comments. Now, image a victim who came along and will those post a comment. That's when the attack triggers, and their session cookie gets snatched. And why does it matter? Because it's a real-world workup call, and our demo will show how cross-site scraping can lead to a session hijaction and putting user account and sensitive information at risk. And at first step, we'll simply make a alert payload, and then we will have some advanced cookie safe. About code details, we will explain it during our demo. And it also includes some technical mappings during our attack. In the final, once we stolen about the cookie value, we manipulate it in BERT, and we can see we got the administrator's access. So came to our third attack, we are exploring reflect cross-site scraping vulnerability within a JavaScript URL context. Our goal is to execute the alert function, but we are working under the restriction where the certain characters such as a quarter and parentheses are filtered and blocked by the application. So the reflect input is being injected directly into a JavaScript context inside the page, meaning that we have to carefully craft our payload to break out of current syntax and inject our own code to avoid the block characters. So this demo highlights the importance of the context-aware escaping and the filter evasion techniques in real-world cross-site scraping attacks, and why the current site fitting filter is never enough for security. So for the code version and the code details, we will explain it during our demo. And here is our technical mappings during the attack. Okay, so let's start with our lab. First of all, here is the web page, and to start this one, we need to launch a specific environment. It will take time. In the meantime, we already opened the proxy for the burp, so we can track the history regarding our request, post and get request. And okay, environment is ready. Okay, so let's first of all to randomly will any of the blog and try to simply copy, use simply script as a comment to make sure it works. So to post the comments, we need to input the necessary user information, and we post it. We can see this successful page. Once we click the back to blog, that means we will these comments by the user. We can see this injector window has popped up. The alert function works. And let's check out the HTTP requests in the burp. So in this request, we can see the cookie selection has been sent along with this request, and we're also able to see the CSRF value and the post ID, username, and those necessary information are sending along together with them. And the cookie information are the thing we are going to steal. And let's go back to this page. Let's go back to the home page because we don't want to see that hijack the window every time. So I choose another block and we copied the code we prepared. To detail analysis this code, at the very beginning, we use this window listener DOM loaded to waiting for the page fully loaded before running and ensure the DOM element are available. It's to take the CSRF token. And then we have the document then we have document get evaluate to grab the CSRF token from the page and bypass the protection. And the document cookie is the thing we're going to steal. And the new form data is the form that's including those token, post ID, comments, and the victim name, website, those information. And the fetch function is the key function that sends the data to the server or endpoint with the necessary value we needed. And we then fulfill the necessary information we posted. You can see it's leave comments successfully. Oh, let's go back. We may not able to see the vulnerability because I forgot to match the post ID. Let's double check. This post ID is 4 and this post ID is 8, so it's incorrect. We need to match it, and then we post it again. Okay, another successful. And then we go back to view it. We can see those session information has been posted as a comments. Actually, it's not a real world scenario, but because of we are not able to use the BERT collaborate to set up endpoint to send those information through the request. So we use another alternative method that is to post those information as a comments to display it as a comments. It will make every visitor to view this blog, view those comments, will see this victim comments. It's not a real use case in the real attack world. Just for your reference. Okay, so once we get this session ID, actually we need to take another action. We need to copy this session ID first. Okay, and we need to go to do another action that is logging into my account. We can see nothing user, maybe just the current user. And then we need to go to the BERT to find my account request and send it to repeater. And we replace the session ID to the one we just stole, and we send it. And we can see the request has been executed successfully. And from the render page, we can see we have already got administration access. Whoa, we got it. Okay, then let's go to the second one. First of all, it's the same thing. We launch our specific environment. And because we already prepared for that code, that script, so let me copy the value here. So let's randomly open a block, and then we pass the prepared code here. And actually, this is an encode version, and let's have a decode version to compare them and explain it to you. So the initial part of the string is the post ID, and we then have the ampersand and the single quotes and a closing curly bracket. This is going to allow us to inject into the JavaScript since we are inside the curly bracket. And then we have a comma. The JavaScript, the reason of the comma is we are providing the argument to fetch API. So we provide a comma separate list of the argument, and we have a comma x equal x. And we're actually declaring an arrow function in the JavaScript, and we are building it to x. Typically, we will see the regular brackets being used as an arrow function declaration in the JavaScript. However, they are going to be blocked by the page, so we don't need to use the left or right brackets. We can simply have the x equal x arrow. Then we can open up our code block. Inside the code block, we are using a throw statement, and we actually pass two values. The first value is the arrow alert function, and the second value is the 745. It passes as a common separate list, as we mentioned previously. And we also have open close comments character in between the throw and the on arrow alert. And the result of that is we cannot make use of the space. So this is a way to spoofing the space, open and close comments. With closing our code block using a comma, we are now passing another argument to the fetch API, that is the toString equal x. And we then have the window plus to a single quote as another argument. And then we have a final argument which open a new curly bucket, and we have the value x, a colon, and a single quote. Actually, the last part is just to tidy up the script, make sure there's no error pop up. So we execute it. We can see the lab has been solved, but I already didn't display right. So we go back to the blog. We can see the inject window pop up. So that's all.
Hello everyone, my name is Marlon. The next part is how to mitigate XSS from the perspective of a cybersecurity professional. Part of our demo is implement into the GitHub actions how to prevent this kind of attacks. Now, as we see in our code, we have part of in our codes some vulnerabilities using XSS. Now, the first tool we want to mention is using SAST, Static Application Security Testing. SAST tools analyze source codes for vulnerabilities like unsanitized inputs or insecure DOMs manipulation before the code is ever deployed. Using GitHub Action, we can integrate tools like SonarQube, CodeQL, or Fortify directly into our CI pipeline. Every pull request or code commits get scanned automatically. This ensures we catch XSS vulnerabilities as early as possible before they ever make into the production environment. Now, the second tool or tactic we can mention is using dynamic application security testing. With GitHub Action, we can automate it. That's to like OWASP SAP to simulate real-world attack. SAP can crawl the app, inject payloads, and report if malicious JavaScript is a security. This kind of testing helps catch reflector or DOM-based excess that may not be visible from the static analysis alone. Of course, tools are only part of the solution. Secure coding practices are equally important. Standards like proper input validation, context-aware output encoding, and avoiding inline JavaScript greatly reduce the risk of XSS. By combining this with GitHub Action and the tool we can use in the pipeline, we enforce shift-left security, catching issues in development rather than post-release. Teams can be trained to recognize insecure patterns and get real-time feedback from automated tests. We are seeing a rise of AI-powered security tools that learn from past codes and predict risk patterns. We can add this into GitHub Actions. Sneak is one of those applications we are using and enhance AI review treatment of the malicious codes. With GitHub Actions to continuously monitor for anomalous code behavior and evolving threats. We also recommend content security policies, CSP healers, input sanitation using libraries like Doom Purify or Rasp, runtime application self-protection to stop excess in production environments. But why GitHub Actions? Because it gives us automation, no need to relay or developers manually running scans. Consistency, every commit or PR gets tested. Scalability, works across teams, repos, and environments. By using GitHub Actions as the heart of our SaaS and DATS approach, we are not just reacting to excess threats, we are proactively building secure software from the ground up. So this is part of our demo. The last part is what we get when the tool in our pipelines already scan our codes. As we can see few of the vulnerabilities in our codes. In our case, we have server-side cross scripting, cross-site scripting, as we mentioned. That's it. Thank you so much for your attention. Bye.